When building microservices, we need to care about the internal software system. We need to measure what's happening behind the scenes, record that data, and also react to those values to understand the bottlenecks and perhaps make changes. Hey, my name is Mario, and today I'm sharing with you how to do that using OpenTelemetry, Jaeger, Zap, and Prometheus. So what is OpenTelemetry? OpenTelemetry is a set of SDKs, APIs, tooling, and integrations that in the end are designed for management of telemetry data such as traces, metrics, and logs. Those are the three pillars in OpenTelemetry. And the whole point of this project is that it is a vendor agnostic implementation. It doesn't provide a backend, but it does provide all that specification and configuration, and obviously libraries and packages that you can use with any different programming language. Obviously, because we're building microservices in Go, we're going to be using the OpenTelemetry Go packages. So what is the support currently in Go? Well, tracing is beta, metric is alpha, and logging is not even implemented. But that shouldn't, discourage you of using this package. The cool thing about this is that you can actually use it. And the way they actually have for Go is there are a bunch of different either exporters or the packages for instrumentation or even external vendors that you can use, and they actually work with the currently implemented packages that exist, available on GitHub. Now, the cool thing about this specification is that because we are using the whole point of defining all of these configurations and SDKs is that all of the different vendors will have or are going to be supposedly going to follow the same specification and the same metrics, or rather the same way to define metrics. So you can use different tools to do different things, but at the same time, you can use the current documentation to start defining those values, like key value attributes. Now, I have in the slides that again will be in the link will be in the description. If you want to check them out, you can look at those and you can see how all of this is implemented. The way they have it is that they even have different conventions for different type of calls, like database, for example. If you look at the example I'm giving you right now, you can look at how OpenTelemetry is telling you, use DB system. Just to take an example, use DB system for defining the database that you're using, which you can be PostgreSQL, Redshift, and so on and so forth. But the same idea applies to some other things, like for example, if there is a statement or what operation you're using, and I'm pretty sure you get the idea. Now, all of this in the end makes sense when we are defining the different segments, when we are defining our own interactions with our own API, and I will show you that next. So let's jump into the code. So as usual, the code to all this repo, or actually to the demo of this repo, will be in the link. You can clone it and play with it. I'm using the most recent OpenTelemetry version, I believe it's 0.19.0. And just one thing to keep in mind is that depending on the version that you're using, it's most likely that the examples are not going to be making compile at all. What this means is that you really need to look at the source code, and it's one of those things that I have a problem with when using OpenTelemetry, is that because it's changing so frequently, you may need to change the way you are calling OpenTelemetry, and it could be like a turn off for some people, because obviously if you upgrade to the new version, it will literally fail and not compile. So that's something to keep in mind. Now, the changes I made specifically for this video for covering OpenTelemetry are related to importing everything that we need for exporting data or metrics to Prometheus, tracing data using GorillaMox, logging some data, which like I said before, is not actually supported by OpenTelemetry, but still I want to show you how to log data using Zap. And the last one will be using Jaeger, where we're going to be doing some tracing, distributed tracing between the requests that we are receiving, the requests that we are getting, and I will show you the user interface so you can get an idea of what's happening. Now, after you import all of these different packages, what you have to do is look at the two functions that I have defined here. One of them will be for instantiating the exporter that happens to be using Prometheus, and the other one will be for Jaeger, which is this is a tracer, and the configuration for the tracer and the exporter and the for the metrics is literally just what you see on the screen. Is just instantiate the Prometheus exporter, you set it, and then you go to Jaeger and then you specify that tracer. And what I added as well is for adding some extra metrics is I added metrics for the runtime. The runtime being the runtime of the service that I'm running locally. And I have been running it locally for a while, so you can actually look the tracing in Prometheus or on the Prometheus user interface rather, and you can see how cool that is. Now, other than that, everything else is the same. Oh, so one thing I forgot, because we're going to be adding segments, or rather we're going to be specifying a few different ways to clearly call out the things that we are using when interacting between the different layers that we have on our implementation. We can allow to define those configurations when we are using OpenTelemetry. And an example I can give you is that if we jump to the service package and we look at task, you will notice that we have a span right here. And what the span does is that when we get a request, let's say we're using in this example, this will be the create request or the post request. We get the post, it creates a segment that then we can specify spans, which if you think about it, will be like, think about this, we have a segment and each one of the different calls that we're making, we can define spans. And the idea is that you can actually measure those spans, and perhaps depending on how long or how fast or how slow, that you can make different changes. Let's say maybe the database is taking too long, perhaps it makes sense to add a caching layer in between, and then you can determine by looking at the actual results that are coming from Jaeger and all those tracing metrics that we're doing. So we're doing this on the service layer, and if we go to PostgreSQL and you look at task, you will notice that there is something similar right here. Let's go up, and then you will see that is something similar right here. We are defining a new span that is getting from the context, and if you're not familiar with the context, this is a nice way to sort of pass values between different layers, sort of. And I will definitely cover how context works behind the scenes, but in the case of OpenTelemetry, the context parameter that is passed in is the one that is actually passing down the actual value for the OpenTelemetry segment or trace that is created originally in the beginning. So that way we can refer to the same one, and then we can concatenate that one with the previous one that was created. So if you look at all of this, you will notice that in the end, in main, I'm also defining the what is it? Oh, here, right here, the middleware for actually doing that Gorilla Mux instrumentation that I was telling you. So if we look at the user interface that we built previously, alright, we didn't build a user interface. We're using what is the name? Did I forget to add it here? Yeah, I forgot. So let's add it to the Swagger UI. If you remember, we had a Swagger UI that we implemented previously in a different video, and again the link will be in the description if you haven't seen that one. And what I want to show you is that if we look at one of the tasks that we have right here, what we're going to be doing is we're going to call it using the Swagger UI user interface, obviously, and then we're going to execute it, and you will notice that obviously everything is working as expected. I didn't actually change anything in the domain or anything in the repository or any of that. We are just adding new values to actually define different spans or way to identify where the calls are being made. Now if we look at Jaeger, for example, where are you? Oops, it should be right here. If I refresh this one, you will notice that something just happened. If I jump into the task specifically, because if you notice we're doing the get request, you will notice that there is a request that just happened right here, and it has 3 spans. And this is what I was telling you previously, that there is this request that is happening on the handler layer or the HTTP layer, and it goes then next to the service layer, and then finally it goes into the database. And then you can measure how slow or fast they are, how long it's taking, from looking at the way the user interface is presented. So in this case, this one is taking about 3 milliseconds. The one for the service, this one is taking about also 3 milliseconds. And in the end, everything is taking about 3 milliseconds in all. Actually, no, this is 20 start microseconds. And 20, okay, so you get the idea. There is some sort of a time that is taken for each one of the requests that we're making. And the same idea happens if I go and decide to, let's say I create, where is my Swagger here, and if I decide, let's say I'm creating a new, let's call it new example. Oops, it's a type. No, I don't know how to write example. It's a high priority, and if I run it, it's giving me a 201. That's expected. If I jump into my Jaeger and I find the traces, it is not going to be here, because if you notice, the operation that is selected is not the right one. But if I look at tasks and I find traces, you will notice that it's right here. And again, it has 3 spans, which are the different calls that we previously defined, the call to the service.create, the service task create, and also the task create on the PostgreSQL package, which is defined right here. Which again, if you notice, I was adding, if you paid attention to the way the task is implemented right here, there is an attribute called dbSystem that indicates the database system that has been used. In this case, is PostgreSQL. And if you notice, it's actually right here is a tag that is coming through Swagger, through Jaeger, via the OpenTelemetry SDK, and it's been displayed here back, on the Swagger user interface. This is really cool, right? Now, in the case of Prometheus, because we're doing some metrics, you can see that I decided to define a runtime, which is an implementation that is available part of the official repository that is coming from OpenTelemetry. And the way the OpenTelemetry team has defined a few different exporters or metrics is that you can actually go and look at the official ones, and you can start using them. They have for the net HTTP package, they have for the mcached package from Brad. They also have a few for Kafka. Also, as you can notice, they have the one for Gorilla Mux, and they have a few other ones for Jaeger, Zipkin, and Prometheus. So there are a few different ways to interact with the OpenTelemetry API at the moment, having a specific and concrete backend systems. So going back to the one I was telling you, which was runtime, which is right here. This one, what it does, as you can guess at the moment, is it literally takes the runtime values, like go routines available, how much memory is running, how much time they took, those kind of things like stack, heap, those kind of values. And you can actually use you can actually use that to render different graphs. So if I do, I don't know, go routines, how many go routines are running and execute? Well, at the moment it looks like I'm running 8 go routines, but I don't know. Let's see, heap allocation, and there is some heap allocation that is happening on right now on my server at the moment. So all of this is super cool, and not only that, because all of these, keep in mind that we have an SDK coming from called OpenTelemetry that is not defining a backend, is vendor agnostic, so you can literally connect this to different providers that at the moment exist. A few examples are like Lightstep. All of these will be linked in the description if you're curious. I know that Datadog and New Relic also have some sort of packages that allow you to interact with OpenTelemetry as well. And if you look at the way this is implemented, is that you can actually not only doing that, but it also allows you to measure different metrics between different services when you are connecting and interacting with them. Now, specifically, the thing I'm referring to is when we're calling let's see, if you remember back previously, a few videos ago, we were discussing about using the CLI. We built a CLI using the Open3 API That again, the link to that video will be in the description. But if you remember, it's just basically using the API that we built before, and then creating a new to do a task, updating it, and then getting it. So it's literally doing a few different actions using the Open3 API, which is our REST API. Now, if we go and jump and look at the user interface, what you're going to be seeing is that there is a new CLI app that I just executed right here with this argument, with this environment variable, and then is posting to our own REST API. And if you notice, this is the cool thing about the tracing option that OpenTelemetry gives us, is that you can actually trace and connect different services, and in this case a CLI that is interacting with our own API. So you can determine, hey, this API, this request went through different steps that happen. So you notice that here the CLI is interacting with the to-do API, is using the tasks endpoint, is doing a post, and then is calling the create, and then finally is doing the database call that is happening. That happens to be creating the record in the database. So just consider when we are working with distributed systems, how they connect to different things. This is a fantastic way to determine how all of that is happening. Now, this is not the only thing that is happening. If you go and let's say there are errors, because there are always going to be errors. Let's say I do a priority, an invalid priority, let's call it invalid, right? And that is going to trigger an error. It just triggered an invalid request. All of those values are going to be also saved in our Jaeger user interface, because we're doing open tracing, which is right here. So there is an error that we are measuring it as well, and it says that is a convert error unknown value, which is what we're expecting, which is super amazing, all of this. Now, how cool is all of this? Well, if we think about it, we have a way to, I forgot something. The other thing that obviously, because in OpenTelemetry is not clearly implemented just yet in Go, is the idea of logging. There is also a specification for actually determining and indicating how to log values properly, depending on the fields, depending on what we're trying to save. But sadly, at the moment, the Go package doesn't support that. It's not implemented at all. So the way I'm trying to give you an idea how this is going to work in the near future is that I am using the Zap package that is coming from Uber. I'm just literally defining a new logger. And what I did in this specific simple use case is to define a middleware that happens to be logging and recording the requests that are coming. That's why you see this. Now you might be wondering, what is this metrics endpoint? Well, the way Prometheus works, or rather the way I implemented the integration with Prometheus, is that I define a new handler right here that happens to be the exporter that was defined down here in the tracer, and that one allows Prometheus to actually pull the values from our instance. And if you look at, and highly encourage you to again look at the code, and you will notice that the way it's configured is that literally just pointing to our Prometheus, or rather Prometheus is pointing to our local service, our server that is pointing to the port 9234/metrics, and that's how Prometheus is literally pulling the values from our server. That's how it actually can save and render that data on its end. So that is really cool. So that's how we cover metrics, we cover traces, we cover logs. Now, going back a little bit to logs again, is that sadly there is no way to use those things in OpenTelemetry, but you can consider that if you're using something like a Logstash, or maybe you're using something like a Splunk, you can actually receive the data, ingest those logs, and do something with them. Perhaps build some dashboards, or maybe filter the values depending on the level that you're using, or maybe depending on the message, which in this case I'm using message for the method, but maybe you can define a different field for indicating different things and react to those values. The cool thing about Zap and logging is that it allows you to do some sampling. So you can literally, you don't have to save all the records all the time. you can sample the logs depending on what you're trying to do. And again, this depends on what is we're trying to achieve with the logs. Most of the times logging is not really necessary, unless you're trying to really look at something that is happening frequently, and perhaps you need more information of what is happening. But again, maybe you can use instrumentation for those cases as well. So again, it depends. But we have the option to log with OpenTelemetry. Now, with all of that being said, what are my final thoughts about OpenTelemetry? I think OpenTelemetry is a fantastic idea because it allows you to specify and define the things that multiple services can use and communicate with each other. Literally think of in cases where I'm using Go here and somebody else somewhere else is using Java, or somebody else somewhere else is using C#, and all of us, all the different microservices can communicate with each other and pass down those values for tracing purposes to indicate how our data or how the transaction happened down the different requests. And that is, I think, the whole point of doing all of this, the idea of having a concrete, specific way to define those kind of metrics, and a way to visualize those values as well. Because it's vendor agnostic, you can literally build your own tool or use something like Prometheus or Jaeger, and use it like really easily. Now the problem with this is that literally there is no, the support that currently exists is, you can see that it's not as good as it is. I mean, it works definitely, but it's still a work in progress. That's what I'm trying to say. That's something that you need to consider as well. Now, that's all I have for now. Thank you for watching, and again, if you have any questions, just let me know. I will talk to you next time. Take care.